and welcome back to QT Stadium. We have a fantastic match lined up for you today. I'm your host James Mount, and today I have the legendary Adam Tao down on the sidelines and James Sargent with me here in the box.
Oh, why thank you, James. Today's match is certainly going to be a good one. We see Team 1 going up against the Static Defenders, and if I was allowed to bet, I certainly know which team I'd be backing.
I know what you're getting at there, Adam, and yes, I clearly see Team 1 coming out on top here, but the Static Defenders have taken out some strong competitors previously, so you just never know.
Anyway, let's go check out what is happening in Team 1's change rooms, and what Coach Dan Richards is doing to rev his team up.
And if we want to come out on top, we're going to have handle a lot of situations. Firstly, getting to the ball, driving towards the goal, and determining the best time to kick, and make sure you're avoiding the obstacles. Firstly, it's going to be vital that you avoid key players here, here, and here, keeping at least 5mm distance from them at all times. In order to do this, you're going to use your potential field navigation system, which means this ball's going to have an attractive force pulling you towards it, and these three obstacles are going to have a repulsive force trying to push you away. Once we take the attractive map and minus the forces caused by the repulsion, you should get a nice clean path, avoiding the obstacles and getting into the ball. Because this is mostly a reactive form of navigation, you're going to use these two IR sensors here and here. What they're going to do is, whenever they're activated, you should strafe away from where they're activated, because it means an obstacle is sitting just outside of your field of view. If there's an obstacle on both sides being detected, the best thing to do is going to be to drive backwards and try and approach the ball from a different angle. Now for some gameplay strategies for your intelligence. If you're down here and you can't see the ball, best thing to do is do a full 360 rotation and see if you can find it. If you can't, drive towards your nearest goal and spin again. Once you're there, if you still can't find it, over to the next goal and keep spinning. Just keep repeating this pattern and eventually you'll find the ball. As soon as you arrive at the ball, you want to make sure you're lined up for goal. Now if you're in this sort of situation where you're facing out here and the goal's over there, best thing to do is going to be to spin around the ball until you're facing the right direction. Then if you're in range, kick for goal. If you're not, start driving towards it, making sure you're avoiding those other players, and kick once you are in range. If you can pull off all of these tasks on the day, we'll meet all of the requirements set out on it.
We will now get the first glimpse of Team 1 as they come out onto the field for warm-up. And don't they look ready to go? Let's take a quick look at what makes this team so special. So let us first check out this player's physique, and what an amazing one it is, which is completely within competition rules. This player is no fragile princess dancing around the field like some of those Italian players you see these days. He's covered completely in a 3D printed shell, meaning this guy is extremely robust to wear and tear, and it takes a lot to break him. This casing is further reinforced through MDF ribs, and a further 3 plates that also double as the mounting points for all his internal components. Now let's take a closer look at some of this guy's more prominent features. The most prominent feature being the 3-wheel omnidirectional drive system, utilising custom Omni wheels and 298:1 low current Palula motors, allowing him to move at speeds up to 6 cm per second. Yes, that means he isn't the quickest guy out there, but he definitely isn't going to be pushed off that bull too quickly. Also, I do know that this guy originally had motors that reached speeds of 15 cm per second, but unfortunately that just meant he didn't have the range of movements required and slipped all over the place. What also should be noted about this competitor's physique is he has all his heavier components, the motors, battery and solenoid, just above the clearance plane, ensuring his weight isn't being transferred between his wheels as he accelerates. The other prominent feature is his glorious bend it like Beckham kick. Using a 24-volt DC linear solenoid boosted up to 50 volts, it allows this guy to score goals from past the halfway, with kick speeds reaching up to 0.9 meters per second. Anyway, that is enough about this player's glorious physique. Let's hear what Adam has to say about this competitor's amazing circuitry.
Thanks, James. Moving on now to the internals of this little beast, we can see a multi-level arrangement of circuit boards inside. To begin with, we've got a 1000 mAh lithium polymer battery hidden out of view just under the lowest plate. This little pack kept the player running for well over the 30-minute specification, allowing Team 1 to train hard out on just a few hours sleep. Supplied through a 2A fuse for safety, the LiPo is connected to the main board, where that supply is split 3 ways. The first split is to the 5-volt linear regulator. This regulator is a reliable piece of kit that powers the logic level components on board, including the Arduino Nano. The second split is for the DC motors. Dropping that 7.4 volts to a safe and unvarying 6 ensured repeatable speeds from morning to night. The final split was to the onboard boost converter circuit. Driven by the small IC shown bottom right, the LiPo's 7.4 volt supply is boosted to an impressive 50 volts. Given the huge boost in voltage, the inexpensive MC34063A was only able to supply an eighth of an amp before frying. Nowhere near enough current for this player's intended kicks, a massive capacitor was added on board. Hidden under the top plate, this new in-development board hosted a 3,300 microfarad capacitor and the circuitry required to charge it. On command, this board would then switch the solenoid's leads to the capacitor, triggering a powerful kick. This configuration outperformed the kicker specifications of half a meter per second, as mentioned by James just before. Over to the last of the circuit boards now, we had two phototransistor emitter pairs. Carefully calibrated, these little guys, positioned right and left of the front, filled the player's two blind spots, keeping him on an unobstructed route. The brains of these electronics brings us back now to that blue Arduino Nano and the software running on board. A serial-based interrupt was used for communication, whereby the micro's main task would stop when new serial data became available. Once received, the main task would extract and then send on the motor speeds and any kick command for the solenoid. Finally, a timer-based interrupt was used to keep the navigation system regularly informed of opponents just out of view.
Thanks, Adam. Team 1 has perhaps one of the most interesting players on the field today, having only a single eye and utilising a special lens to improve his field of view. This wide-angle lens increases his range to 69 degrees in the horizontal and a massive 90 degrees in the vertical, improving his ability to quickly find the ball. It also allows for him to detect whether the ball is in his possession while still capable of seeing his opponents and goals. Using some performance-enhancing functionality from the OpenCV library, the player is capable of detecting the ball, yellow and blue goals, multiple opponents, and the walls surrounding the field. A color calibration method allows for the player to adjust his sensitivity to each of the objects with a few simple taps. Working in the HSV color space, color thresholding is applied, followed by morphological filtering, identifying contours, and a variety of false positive filtering methods, making sure there are no distractions to his game. In order to do this at the required speed, multi-threading was implemented, allowing for the differently colored objects to be processed in parallel, keeping him thinking quickly on his feet. Other processing optimization methods include downsampling for goals, obstacles, and walls, and minimizing the region of interest for processing the ball, as shown here in the light blue box. I have word from the coaching staff that the ball is capable of being detected up to 1.6 meters at a standstill or while moving in the forward direction. However, there are some issues to be overcome while rotating. Goals, obstacles, and walls can easily be detected the length of the field and should not prove difficult for this guy. Direction and distances of objects are estimated using known real-world dimensions in comparison to pixel measurements at known distances, giving him the ability of estimating object positions to suitable accuracy. Abstracted classes for the ball, goals, obstacles, and walls allows for the player's vision system to relay information for him to perform some of those complex maneuvers we saw Coach Dan outlining earlier. Looks like the coaching staff have set some strict ideals for their player, and while he doesn't seem to quite meet them for today's game, I can't wait to see how he progresses in the future.
Well, it looks like we're just about to kick off, and there we go. The game is underway. With Team 1 making a dominant start, and there's one goal already. Well, this seems like it could be a bit of a tough situation for Team 1. Two defenders, including the ball a little bit. Let's see what he can do. Doesn't look like he's going to be able to get through there. Having a bit of a hard time, he is. And check out that maneuverability. Just easily able to get the ball off the wall there. And what a tackle made. Clearly steals the ball off the defender. No foul there. Just needs to get around the ball now. Line up the goal. And he shoots and he scores. Let's see what he can do here. Just got to get through the two defenders. He's got the ball. Splits the defense. Just got to shoot. There it is, 3-0.
Anyway, before we jump down to Adam to give us a game review, I want to see what James thought of Team 1's management and coaching staff. So mate, your honest opinion?
Well, James, I thought the team performed well as a whole. I hear that early training sessions led to a good schedule for the team to follow, and that seems to have shown in today's match. The captain chosen early on didn't need to throw his weight around much, with all team members playing well together and in their individual positions. Some minor communication issues from all players in updating team members on their progression found them wanting early in the game, however they really showed themselves a solid team towards the end. Inexperience in some tasks led to underestimation of completion times and overrunning of the ball. For the most part, they managed to complete their plays as originally intended.
No, I definitely agree with that. There were definitely some minor hiccups, which I heard happen throughout the whole time, but I think the team collaborated pretty well and came out strong and ended up giving a damn good shot, so yeah, I agree. Anyway, that's enough of that. Let's throw down to Adam to get a game review and his opinion of the game.
Thank you. As you know, this is a new team, and so a lot of time was spent working out which players would work best together. The team we saw today had an Omni-Drive system with in-house custom design wheels. They used a monocular, wide-angle lens for vision and a solenoid kicker. No dribbler was seen on the machine, however, this certainly didn't draw from their performance today. Just check out this play, most definitely the highlight of the game for me. The navigation system tirelessly drew information from the vision and electrical systems, giving the robot the ability to locate the ball, precisely navigate the obstacles, reach the ball, sidestep that last obstacle, move to a clear line of sight, and finally kick to goal. With the 3-0 victory a strong win. Team 1's performance today was cohesive to say the least, demonstrating tightly integrated subsystems that the robot drew on with each intelligent gameplay decision made.
Thanks for that review, Adam.
Just before you sign off there, Matt, I'd like to see what the previous team members of Team 1 had to say about the game. Obviously, they're still a bit cut from being dropped from the team.
Yeah. Anyway, they should move on. Anyway, with that, that's the end of today's soccer game, with a 3-0 win to the Team 1. Great match to watch. Anyway, cheers folks, catch you next time.